Alright, now that we know how to graph quadratics in any form, we can do some examples where you just start with a general equation in any of the three forms, and you use that to find all the other parts of the parabola and then to graph it. So the important things you have to remember that you're searching for when you do a graph to make it look good are obviously the vertex, but you also want to have the x-intercepts, which are called the roots, the y-intercept, and you got to be aware of the stretch factor when you're drawing it to make sure you stretch or compress the right amount. So you want to draw your graph, you want to label your axis and draw it in such a way that you have all these important parts shown. And so you might not always be drawing it right centered on 0, 0. If the graph has been shifted left or right or something, you want to take that into consideration when you're drawing your picture. And to find all these different things we need, we're going to just practice converting the forms. So we have a couple of examples where we're really going to put together everything that we've learned. Our first example is graph and find all the important information for y equals x squared plus 4x minus 3. So the first thing you might be trying to think is, okay, let's try to factor it. So you go like this. Can I think of two numbers that multiply to 3? Well, certainly a 3 and a 1. One has to be negative, one has to be positive. Well, if I make this one negative and this one positive, that's not going to give me a 4. If I make this one negative and this one positive, that's not going to give me a 4. So factoring does not seem to work. Okay, let's think about something else we could try. Let's try to find the vertex. The x-coordinate of the vertex, if it's in standard form, we know a shortcut is negative b over 2a. Well, that's negative 4 over 2. So the x-coordinate of the vertex is negative 2. Let's find the y-coordinate of the vertex. We can take this value and plug it in, and we get negative 2 squared plus 4 times negative 2 minus 3. Okay, that's positive 4. That's negative 8. That's negative 3. Okay, so 4 minus 8 is negative 4. Negative 4 minus 3 is negative 7. So our vertex is located at negative 2, negative 7. That's cool. We know the vertex. We know the line of symmetry then is at negative 2. So we also want to find the roots and the y-intercept. Well, the y-intercept we can get just by looking at the equation. It's negative 3. So 0, comma, negative 3. And it would be really nice to get those roots. So to get the roots, if factoring does not work, you can use the quadratic formula. So to find the roots, we're going to use the x-intercepts are negative b plus or minus the square root of b squared minus 4ac. Again, that's the quadratic formula, all over 2a. So let's plug in our numbers. Negative b is negative 4 plus or minus the square root. B squared is 4 squared, which is 16, minus 4 times a times c. I'll write it out. 4 times 1 times negative 3, all divided by 2a, which is 2. So we get negative 4 plus or minus the square root. That negative and that negative cancel out. 4 times 3 is 12. 12 plus 16 is 28, divided by 2. 28 is the same as 7 times 4. And 4 is a perfect square, so we can write this as negative 4 plus or minus, the 7 is trapped inside, but the square root of 4 is 2. So 2 root 7 over 2, which equals negative 4 divided by 2 is just negative 2 plus or minus the square root of 7. Okay? And again, this should match up with what we thought, because the negative 2 is the location of the vertex, x-coordinate, and the plus or minus root 7 tells us how far we're going left or right. And we could see that right here, because we've got that the y-coordinate of the vertex is down 7. So you know it's a parabola that's not stretched. So if you go over square root of 7, you'll go up 7. So it makes sense that the two roots are spread out square root of 7 in either direction. So let's draw on our axes. We know that we want the vertex at negative 2, negative 7. So we should probably put our axis maybe a little bit to the, not exactly in the middle, and also a little bit higher than normal, something like this. And we should always put arrows on the end. Label the x-axis, the y-axis. So if we go down to negative 2 and 1, 2, 3, 4. Let's label as we go. -2, -4, -6. So here's -7. So here's the vertex. The y-intercept was at -3. And you can see right away that that is over 2 up 4. So that matches what we think. Over 1 up 1. Back 1 up 1. Back 2 up 4. We can even go over 3 up 9. That's going to be at a 2, and then here, over 3 up 9. And where we cross the axis is at -2 plus or minus root 7. So here's a -2. There's left root 7, and there's right root 7. Okay, so we draw in our parabola, going through all of these special points. We've got the roots, root right here, and root right here. We've got the y-intercept right here, and we've got the vertex right here, and we've got the line of symmetry right down the middle. So there's everything about this parabola that could be known. We know about it by converting all the different forms. All right, next example. This one we have in factored form. So the first thing we notice here is there's a minus in the front, which means it's been reflected, so it's going to be upside down. It's in factored form, so we can immediately get the roots. Opposite sign of what you see, so 4, 0 is one of the roots, and the other one's going to be -2, 0. To get the vertex, we know that the vertex is halfway between the roots. Halfway between those two is 4 plus -2 over 2. That's going to be 4 minus 2 is 2, divided by 2 is 1. That's the x-coordinate. To get the y-coordinate of the vertex, we take that and we plug it back in the original. So we have negative times 1 minus 4, 1 minus 4, times 1 plus 2, 1 plus 2. That's negative times -3 times +3, which comes out to be +9. So our vertex is located at 1, 9. That's useful to know. We got our roots over here. I want to mention again that the two numbers came out to be the same number because the vertex is right in the middle, so it's equidistant left and right. The vertex is at 1, 9, so we're going to have to draw our axis. Our x-axis we should draw low on the graph so that we have the ability to go up 9. So you want to make smart choices about where you're drawing your axes so that you can fit the parabola that you're trying to draw really well on here. So let's go up. There's 3, there's 6, there's 9, over 1 up 9, over 1 up 9. So there it is. It's not stretched, but it is reflected downward. So just by looking at the graph, we can tell the y-intercept should be right here at 8. Because if you go over 1 and down 1, over 2, down 1, 2, 3, 4 should be this point and this point. But let's verify the y-intercept to get the y-intercept. So to get the y-intercept, we could either convert the entire equation into standard form, or we could just plug in x equals 0. So let's try plugging in x equals 0 and see what we get. We get y equals negative of 0 minus 4 is just -4, and 0 plus 2 is just 2, and negative times negative is positive, 4 times 2 is 8. So we get 0, 8, which is what we knew. So 0, 8 equals the y-intercept. And that's what we knew from the graph, but it's nice to kind of just confirm using our skills with math. What are the roots? 4 and -2. So here's a root, and here's another root. And again, from the vertex, if we go over 1, 2, 3, and down 9, we see that's right where we hit, or left 3, down 9, we can see that that's where we hit. So we can draw in this parabola. Again, mine is a little sketchy because I'm drawing it with a mouse, but it goes through the correct points. So having these special points labeled, the y-intercepts, the x-intercepts, the vertex, and over 1, down 1, over 2, down 4, that's really what shows you understand what the parabola is doing. It's not how well you draw the line, although you do want to try your best to go through those points when you're sketching in the line. So you can find the roots, the vertex, the y-intercepts, the stretch factor, or if it's reflected, all that kind of stuff by utilizing these techniques of finding the vertex form, the factored form, and the standard form using completing the square or quadratic formula, or that the coordinate of the vertex is halfway between the roots. So all these tips and tricks that we've been learning in Chapter 9 allow you to draw any parabola very accurately. Alright, so just keep practicing and ask if you have any questions in class.